What if I told you there was a tool that could automate your machine learning pipeline? That all you had to do was give this tool a data set and it would evaluate that data using some of the most powerful machine learning algorithms. That it would tune your hyperparameters for you and that it could give you over an 80% increase in your computational speed. The automl function through the h2o package can do exactly that, all without requiring you to leave RStudio or learn a new programming language. We're talking all about this incredibly powerful data analysis tool in today's video. Hey everyone, and welcome back. I am the part-time economist, and in today's video, we are talking about one of the most powerful data analysis tools on the market. Well, it's not even on the market because this tool is completely free for you to use, but it is incredibly powerful, and that is the automl function through the h2o package. So in today's video, we're going to explain what h2o is, why you would want to use it, and then after you're convinced it's one of the greatest things in all of data analysis, I'm going to show you how to implement this tool step by step into your machine learning pipeline. So with that being said, number one, what is h2o? h2o is essentially its own program. Now, there's a lot of things that we could say about h2o, that it uses a cluster, that it relies on Java, that it does all of these things. But for our purposes, there are two big takeaways. Number one, h2o has functionality, features that are not present in traditional R. Number two, because h2o uses Java, it is much faster than a scripting language like R or Python. So what we want to do is use h2o to get access to those benefits. So just as an example here, I created a really rough comparison that shows if you were to run the exact same model in traditional R versus the exact same model in h2o, you could cut that computation time by upwards of 80%, which is awesome. But increased speed is not why you are here. You are here to learn about automating machine learning, which is exactly what the automl function is designed to do. So let's go ahead. We're going to run through some examples, show you how to implement this feature. Now, the first thing you need to do is make sure you have the h2o package installed, the mlbench package installed, and tidy models installed. If you already have them installed, you can just pull them into your workspace using the library command. If you do not, you will have to install them using the install.packages command. Make sure that you put the package name inside of parentheses when you run that command. And of course, you shouldn't have the hashtag. That's just so I know it's a comment. So we pull all of these packages into the workspace. Now we need some data to work with. So we are going to be working with Boston housing data. Now, this is just a data set of various houses in the Boston area. So it has the crime rate, it has the average number of rooms per house, whether or not it's by the Charles River. Just an interesting data set for us to look at. So let's go ahead and assign that data set to a variable. And of course, you know, you can call your variables whatever you want. I'm calling it new h2o data. So that is the h2o data that we're going to be working with. And, you know, in data analysis, we have to split into the testing and training sets. And now let's go ahead and take a look at that data and see if there's anything interesting we might want to analyze. So we might want to see what factors impact the crime rate. And we might just suppose that maybe the crime rate depends on the proportion of older houses, maybe the tax rate matters. The number of rooms probably doesn't matter, but we just want to include some variables for the analysis, right? So we're going to select those and bring that into the new variable. So everything we've been doing so far has been in traditional R. Select function, if we were doing mutate functions, anything like that is traditional R. What we need to do to make use of h2o, because remember, I said that h2o is essentially its own program, and it is. What we're doing when we use R, or if you're accessing h2o through Python or a different language, because it does support multiple languages, but when we are accessing it through R, we're essentially just tying in to this h2o cluster. So just like any program, we need to launch it. And we do that by using the h2o.init command. What that will do is it will launch the h2o cluster for us. What's a cluster? How does it work? You don't necessarily need to know that because it's going to create all of that automatically for you. If you want to fine tune this, you can look up the h2o.init function, the help pages, and it will show you how to customize various aspects of this function. But again, just to get started, you definitely do not need that. Okay, so we have h2o up and running. Remember, it's a separate program. We have this data set where we've selected a couple columns. That is still sitting in traditional R. We need to move that over to the h2o cluster. The way we do that is by using the as.h2o command and then passing in the name of whatever variable we want to carry over. So we are moving the new h2o data. And okay, perfect. So we've got h2o running. We've got our data. Let's do some analysis. Super simple. We need really 2 to 3 things we have to do. So the first thing we need to do is we're going to assign a variable, and this is just to hold the output. So we're going to call that automl. We then use the h2o.automl command. We pass in the y variable, and this is the column name that is our dependent variable. So in our example, it's CRIM for the crime rate. We then pass in the training frame. That is all you need. However, I'm also putting the max runtime argument because if I don't, it's going to sit here all day. So I'm going to go ahead and run that. And while that is running, I do want to point out, I didn't put in an X variable. Why didn't I do that? If we just pass in a Y variable, h2o is automatically going to treat everything else as the X variable, the explanatory variables, the independent variables, if you will. So that is going to be done for us. And then once that finishes running, we can pull up this automl variable that we created and we can see all of these different models. So it trained 20 different models for us. Now, the cool thing I want to point out is that it trained a variety of models. So it did a stacked ensemble. It did a gradient boosted machine model. I'm sure it probably did a linear model somewhere in there, right? So it did a lot of different models, but it also did the same type of algorithm with different parameters, which is really cool. So this is a list of all the different models it trained. How do we actually make sense of that? All we have to do is pull out the best model. And the way that we do that is by using the h2o get best model command, passing in that variable that we created up here. And what it's going to do, it's going to go in that list. It's going to pull out the best model for us. And if we wanted to look at that model, we could pull it up. We could see all of the key metrics for the model. And then we could also see what type of model it is. So it's the GBM. Now what we want to do, we want to use that model to make some predictions. All we have to do is use the h2o.predict function. We're going to pass in the model that we're using for the prediction and then the new data set. Keep in mind, because h2o is its separate program, we do need to bring that data set into h2o. We can do that by using the as.h2o command, just like we did previously, and then we can go ahead and run that prediction. So after we run the prediction, we can see those predicted values. Okay, so that is very basic. That's literally all you have to do. And I want you to take a minute to think, how long would it take you to code 20 different models with different sets of hyperparameters in traditional R? Not even counting how long it's going to take that to run. So just using the basics out of the box, you are light years ahead of traditional R. But you can still improve. And what I like doing in these videos is first showing you the basics to get off the ground without being overly complex, and then slowly adding refinement and nuance so that you can fine tune things if you want. So the first thing we're going to do is we're going to add some additional parameters. Now, where are these coming from? These parameters are all coming from the automatic machine learning documentation in the h2o.automl help page. So as you can see here, there are dozens of parameters you can adjust. I'm only going to cover a couple of them. Number one, because they're the ones I use most frequently, but number two, just to show you the point of how it works. If there's something you're trying to adjust, you can find it, and the process is similar. So everything up to this point is the same. We're still passing in the Y variable. We're passing in the training frame. I'm adding the number of folds, so that is for cross-validation. Runtime of 20 seconds is still the same. This time I'm telling it, I want you to sort these results by RMSE. Now, Again, if you look in the documentation, you can find other ways of sorting. Maybe this is important if we're doing some kind of a competition where they say your results will be evaluated on RMSE. Well, then we want to build our model on RMSE. The last thing that I usually put in is verbosity equals info. And what that does when you run this, you're going to see that it tells us a lot more about what it's doing. So it says, I'm trying this model. This is the best performing model. And you don't by any stretch have to run this. I just like seeing it, knowing that the computer's working, that it's not frozen. And then also it allows you to see how your model is improving with each new iteration of a model that it's training. Alrighty, perfect. Once that finishes running, we can go ahead and pull out the best model. We do have a little bit of control where we can fine tune things if we wanted the best model, but we only wanted the best linear model, for example. We could find that by using the same get best model command, passing in the container that's holding all those models, and setting algorithm to GLM. Likewise, if we wanted the best GLM model, but we wanted the best to be evaluated on RMSE, we could do that by passing RMSE into the criterion. If you don't know which options are available, you can find that using the h2o.getBestModel, and it will tell you all the different algorithms as well as the criterion that you can select by. But that brings up a really good point. Why would we run, that's a hard thing to say, why would we run 50 different models, all these different algorithms, just to limit the best model to a linear model? Well, the short answer is that we don't have to do that. So if we know for whatever reason that our analysis has to use a specific model, maybe we have to use XGBoost as an example, right? Let's just suppose we're doing a project and it says you must use an XGBoost model or you must use a linear model. We can tell AutoML, just use this algorithm. We still want you to identify the best hyperparameters, but use a specific algorithm. And I'm essentially calling that the lazy tuning method because we're using that AutoML functionality, but we're just tuning hyperparameters, which still is much faster and, in my opinion, much easier than doing some kind of a grid search with tidy models or even a grid search in h2o. So the way that we do that is by using, again, everything is the same, h2o.automl, y equals the dependent variable, training frame, endfolds, max runtime, all of that is the same. Sort metric, again, we're just telling it we want to sort the results by RMSE, and then we are passing in the specific algorithms that we want to include. So I'm saying XGBoost. I could do multiple algorithms. So I could say just run these two or run everything but this one by using the exclude algos command. And again, you can find all of these different options in the h2o.automl documentation. I'm not going to run through all of them. One last thing I do want to say before I close out the video. Usually, I limit how long this runs using the max runtime in seconds. So I'll run it for an hour, 2 hours, whatever the case is. However, you can also limit this by performance improvement. So you can tell h2o to stop running if I'm only improving by 0.01%, right? So there's lots more that you can do with AutoML and h2o as a whole, right? It's an entire program like I mentioned in the beginning of the video. So there's a lot more you can do with it, but just knowing the very basics, even if you forget everything we said in the second half of the video and you just focus on this simple command right here. AutoML, training frame, dependent variable, max runtime 1 hour. That is going to totally change how you look at machine learning. So I hope you found this video useful. I do appreciate you watching, and I'll see you in the next one.